Okay, gang, I've been through your PowerPoints for the beam data and wanted to give you just a little bit of feedback. If you have not watched feedback from the other 2 years, I strongly encourage you to do so before you create the DOE for your final presentation, because I'm not going to cover all the things that I do in there. I'm just going to hit a few highlights from what I see in your alls. So definitely encourage you to watch that. Okay, the other thing I want to say is when I presented my story when I was going over that lecture, I really didn't pay any attention to what my slides looked like or labeling, all that. I was more giving you an example of how to break the data down. So if that led anybody astray, I'm sorry about that. I'll just say that right up front. Okay, so let me start. I picked Erin's. Erin did a good job telling her story. There's still some things in the slides that she could have done differently, and I'll point those out. But just in terms of telling the overall story, she did good. Now remember, for your final presentation, you're going to need to tell about your question, how you went about answering it, your method, all that before the data. We're just jumping right into the data. Okay, so one of the things I like what Erin did right up front is she highlighted and told us, okay, her error bars are 3 standard deviations. One thing I would probably have marked on here also is it's 3 standard deviations of the average, because all of your error bars are on averages. I probably would have even put 3 times S sub X bar to highlight that it's a standard deviation on the average. But it's very good just right up front telling everybody, so that way there's no question all the way through. So then she starts her story off with 30 versus 100, showing this, talking about the confidence intervals don't intersect, therefore the modulus of elasticity are different. Another way to say that is, okay, your factor was infill. You could say infill, the factor infill does matter. We have to analyze the data for the two separately. Then she goes through and 30% side and up. You see on the slide, it's real clear what she's doing. So she comes down, the confidence intervals fall close. They can't be explained by themselves with the graph. So then she goes to the t-test, tells the t-test. I'm going to come back and talk about this in just a second. I want to just kind of go on with the story. Then she says 100, and there's no evidence that they're not the same, so they can be combined. She said we're going to do the confidence interval just to show, and so here that is in the conclusions, and then she hits with the conclusion. And notice in telling her story, she said that for 30% orientation matters. So she presented a modulus for 30 side, for 30 up, and for 100 it didn't, so she just presented one. Now, it's important. What were we trying to do? We were trying to determine the modulus. So that's the bottom line results that you want to give. Okay, so I'm going to go back up here to this guy just for a second on the t-test. For one thing, I'm going to show you an example in a minute from Brianna's. You don't have to give this whole thing for your t-test. You could just give the essential information that you need. It's kind of cool, you know, how you put this on here, but my suggestion for a presentation, don't make me go to a legend to see what things are. It would have been just as easy to come right here and put T critical, and to come right here and put T actual, you know, big words or a box right there. You know, don't make me have to work to try to get what you're telling me with that visual. And then let's see, and it would have been a good case right there, your probability, to come right here and put an arrow like that with probability 0.54. The probability of getting a value that big or larger, if the two averages really are the same, is 0.54%. Okay, so that's an example of telling your story. You're taking the person through until finally here's the conclusions in terms of what, for us, we wanted to know what the modulus, here's what you can expect. Okay, so one thing right from the very, very beginning, it's nice to give the big picture. And so here's some examples of how people give the good picture. Now, like, for instance, like on this one, I probably would have made the words smaller, moved them over, and then made this graphic larger. But notice you see 30%, you see 100%, you see side and up. Here's another example of how somebody did it. Again, it's very clear. You're giving the person the big picture of the beginning with the data. Here's another way somebody did it, where they had them broken down like this. So that's one thing I would have done up front, is given the big picture. The other thing is, when you went 30 showing side up, engineers like details. Whenever possible, you want to give your graph and you want to give the numbers. That way, if something doesn't look right, if someone's like, well, how did you get that? You've got the numbers right here to show it. I personally like to have the raw numbers and then the averages. It's just my thing. That way, when I look, I get an idea myself how consistent things are in the numbers that you're showing me there. Here's and I did make a note on this. This example I grabbed, this person only did 1 standard deviation of error bars. That's not good. They should have done at least 2, probably 3. But the layout that they used is what I really wanted to show you in this. And so you see, here's where they did 30 side and up, same thing, but you see the layout. That way, all the information is there that I would want to see as an engineer. And I'm going to show you some examples in a minute where the graph doesn't look good, something looks wrong, but there's no numbers to see, okay, where are things really coming from? Where did things go wrong? And then here's another example. Again, you just see everything right there all together. Okay, so I mentioned Brianna. Here's hers. So she starts off, she does the same thing about the giving an idea of what the error bars are. Let me go back one. On this, again, instead of a bunch of words, I would have had real big 3S X bar. Then bammo, it's obvious right there without me having to read a lot. Then I really liked this overview where in between here and here, I would have liked that graph I was showing you before. Just, big picture where you see the raw data. But then the way Brianna summarized this, I really like it, because you get to see right here really quick, 30 and 100, obvious difference. You get to see 100 side and up, 30 side and up. Right away, you're kind of clued into, hey, maybe we need to look at something here. You know what? Yeah, probably not at all. And so this would be a great place to give an overview, and we need a little bit more analysis. So then that's where jump in, and what I wanted to show you what she did here that I liked. She drew the conclusion, yep, that's too close, we need a t-test. She comes down and does the t-test, and she just gives the key information that's needed from the t-test. Instead of just text like that, I may have put it in a box over here and just highlighted those numbers, but I really like that. Notice also it's really clear, orientation of 30% fill. You know what this graph is about. When you're doing your presentation, one of the things I mentioned in the video about doing presentations is big picture, small. You'd want to say, okay, so now this graph is showing the orientation for the 30% fill. It's going to let us see the difference between side and up. Bammo, I just oriented you to get my light back on. There we go. To what's on the slide, what I'm going to show you. Now I can draw your attention to what you're going to see. Now, one thing is, look at all this white space. I would have changed the scale. Maybe had it start about 250,000. And you'll see several examples of this, but don't just use the default that Excel gives you. You could have right-clicked on these on these numbers right here, when it was in Excel still. And you could have said format number, and you could have put a comma there. And those numbers would have been so much easier to read. You could have bolded them. You could have made the font bigger. Do those things for your presentation. Don't let Excel tell you how the graph's going to look. You make it look like you want it to communicate the things that you want to communicate. Same thing, she did the same thing with 100 just to show. And then again, bammo, the summary. Gave the modulus for side, gave the modulus for up and 100. And the variability within it and made it clear it's one standard deviation of X bar. Now, since we're presenting what I can expect for the modulus, I wouldn't want X bar here, I would want X. So by putting that, it's easy to see, oh yeah, she used the wrong standard deviation or she labeled it wrong. But when you're comparing averages, you want the standard deviation of X bar. When you're presenting what you can expect out of one piece, you want the standard deviation of X itself. Okay, here's one from Andy. I really liked this intro that he gave. Very clear overview of what he's going to go through and present. Gave us a little bit of his methodology. Again, you didn't have to do this for this presentation. And then he gets into the results. His is one of the ones that gave this big picture, what I liked. But then he kind of dropped me. He didn't tell the story. He just started listing results. He didn't take me through graphs that showed me that story. So just be careful about creating a story to take the audience through what you need them to know. And then same thing here on conclusion. The objective was, what is the modulus? And you're given it for 100 and then 30, then 30 side and 30 up. Well, if we determined that 30 orientation mattered, then is there such a thing as 30 by itself? So again, be consistent with your conclusions and what you present in the end. And I like how he asked for questions, gave some references. So here's one from Jared. Jared did a nice job of having the numbers and the averages on here. Remember when I showed you in the examples, I was talking about how, I also like to have the raw numbers if I can. It just gives me context for the averages. But it was nice how the numbers were here so I could see what was going on. And, look real clear here, T equals 3. Again, T what? You would want to make sure, because you can't assume your audience knows what T is. You would want to make sure you highlight, okay, these error bars are 3 standard deviations. Here's what that means. And again, you see the white space right there. Watch out for your lines. You don't want lines between your points. It really confuses things. I'm going to show you one where someone left lines on, and I really had no idea what the graphs were trying to show me. And then just your font, this graph is small. It's hard to read the things that are important to me. So just remember to go through, and you can change all that. If you don't know how to do it in Excel, see me. I'll be glad to help you. But you can make your graphs look like you want them to look well for your presentation. Whoops. Okay. Now here was one, and my first thing was, I don't know who this is. When I exported all the PowerPoints, there were, I think, 2 or 3 people who I have no idea who the PowerPoints went with. Remember, your things should stand alone. Now, this is nice because it shows the big picture, like right here. You should have expanded that so it didn't wrap like that. But the thing I wanted to point out on here is use the correct terminology. This is for all of you. These are factors. That's a treatment. So side 30, you have 12 data points at each treatment. So use those terms as you're drawing your conclusions, where you find, okay, the factor fill percentage definitely matters. The factor orientation does or doesn't matter for 100%, or does or doesn't matter for 30. Because then you come in here, obviously this graph, and this isn't the only person, where there's no labels, I have no idea what it is. The other thing, the average between can be analyzed differently because the street, what does that mean? It's the factor fill definitely impacts, because 99% of the points are going to be contained in here, and so there's no way that these averages are the same. That means the factor fill did impact, so 30 and 100 are different. These averages are not the same. The average at 30 is not the same as the average at 100. And again, just terms, need to use t-scale. Remember, it was a t-test. And then same thing as before, the objective was to get the measure of effectiveness, make sure that you give it. You give the bottom line conclusions of whatever it is you were trying to accomplish. Okay, this was another who. I mean, obviously the graph, and I guess the thing I want to point out to you guys, you have to learn sooner than later, is that all of the little bitty details matter. The only thing someone is going to know about you and the kind of work you do is what they see in this presentation. And so you have to ask yourself something like this: what does it communicate? What does it communicate about me? And I know all of you, and I know none of you do the kind of work that would be communicated in a graph like this that you went through. So just pay attention to those details, because it really does matter. And a presentation is how people in the organization get to know you. And so you want to communicate to them through the quality, through the level of detail, the type of person you are and work that you do. Okay, this one was nice, where they had the big picture, then they brought their averages in, and they did the same thing with the side and the up here. And the only thing I pointed out here is it says, where did that, yeah. It says significantly higher values. What does significantly higher mean? Remember, engineering, you got to be specific, precise in your terminology. And then, same kind of thing as we saw before. Here's their summary. But why 30 and 100 and 30 side, 30, I mean, like, why am I seeing 100 side, 100 up? If the side and up different didn't matter. The whole reason why you're doing the experiment is to determine which factors mattered. If you find that a factor doesn't matter, then what that's saying is there's no difference in the averages. There's no difference in the data from 30 to from 100 side to 100 up. So I can average it all together as an estimate of what the modulus is for 100. So in this case, everything, all the side and up, should have been brought together and just given that number right there. So whammo, you didn't need side and up, and you don't need 30. You need 30 side and 30 up because you determined that the factor orientation does matter for 30. So again, on this one, get rid of the lines. And note this graph of graphing them on top of each other versus the previous graphs of doing them side by side with the boxes. And you've got to just decide which you think communicates better. I like the side by side with the boxes. I think it highlights differences better. And then I come down here and like I have no idea what the error bars are. And without any numbers, I'm just guessing. And then I go to this next graph and I'm like, okay, something looks really off here. Because up here it says looking, you see all this overlap, but yet my error bars don't overlap. So I'm thinking, something is wrong here. And then it says using a t-test, we found that the averages are close enough to be able to read as the same. In other words, orientation did not matter, but it doesn't fit this graph at all. So another good example of why it's important to have the numbers, because we can't reconcile that at all. Now, this graph showing side and up 30, this would have been really nice with this one. Now they're actually in opposite order on this one on the other one. But if you had taken these and had them over here, this would have been a really nice picture showing that, and then you could have made the points about it. And this was the one I really couldn't tell what I was looking at in any of these graphs because the lines were on there, and I don't know whether like this was left over, whether that was supposed to be there. It made it really hard. The other thing is just, again, be precise, be careful. It says, in comparison, the 30% modulus of elasticity is different from the 100% fill. That doesn't make sense to me. I'm comparing modulus of elasticity to 100% fill. I think what the person meant was that the modulus of elasticity for the 30% fill is different from the 100% fill, but that's not what it says. So just slow down, Be careful, be precise. The only thing someone knows about you and what you know is what you're communicating in the written things that you give out. Here's another one where I think this person used the standard deviation of X instead of X bar. These error bars shouldn't be that big. Again, without the numbers, it's hard to say, but I'm pretty sure that that's what happened here. And this one right here, you know, it says the t-test verified. The t-test should verify that orientation did matter. So if you're having trouble doing that correctly, make sure you see me, especially when you're analyzing your other data, and I'll be glad to help you. And I think that's it. So hopefully between the videos from last time and some comments on here, it will help you formulate a good story to tell for your final presentation. And again, if you haven't watched the video on doing presentations, I highly encourage you to, because this is different than anything you've ever done before. This is not a high school speech. This is a technical presentation and you need to prepare for it as such. So good luck, and if you need help,